Welcome to another episode of AP Computer Science. Often the data a program uses comes from a two-dimensional situation. Example, maps are 2 dimensions or more. The layout of a printed page is 2-dimensional. A computer-generated image, such as on a computer screen, is 2 dimensions. For these situations, a Java programmer can use a 2-dimensional array. This allows for the creation of a table-like data structure with a row and column format. The first subscript is a row index in a table, while the second subscript is a column index in the table. Here is example code, including a diagram of the array table. Two-dimensional arrays are objects. A variable such as a table is a reference to a 2D array object. The declaration defines a table that holds a reference to a 2D array of integers. Without any further initialization, the table holds the value null. This declaration defines a table that holds a reference to a 2D array of integers, creates an array of an object of 3 rows and 4 columns, and puts the reference in the table. All the elements of the array are initialized to 0. The declaration does exactly the same thing as the previous declaration. This declaration creates an array of the same dimensions as the previous array and initializes the elements to the given values in each cell. If no initializer is provided for an array, then when the array is created, it automatically fills with the appropriate values. 0 for numbers, false for Boolean, and null for objects. Just as with one-dimensional arrays, the row and column numbering for a 2D array begins with the subscript 0. The 3 rows of the table are created from 0 to 2. Likewise, the 4 columns of the table are numbered 0 through 3. The array table is filled with the sums of the row and column, which is accomplished by this code. To access each location in the matrix, specify the row coordinate first, then the column. Each subscript must have its own bracket. The length of a 2D array is the number of rows it has. The row index will run from 0 to length minus 1. The number of rows in a table is given by the value table.length. Each row of a 2D array has its own length. To get the number of columns in the table, use any of the following. There's actually no rule that says all the rows in the array must have the same length, and some advanced applications of arrays use varying size rows. But if you use the new operator to create an array, as described before, you'll always get an array with equal sized rows. The routine that assigns values to the array uses a specific number of rows and columns, and that is fine for this particular program. But a better definition would work for an array of any 2 dimensions. In this code, the limits for the loop have been redefined using table.length and table_row.length. So they work with any 2-dimensional array of ints and any number of row of columns. The following illustrates the parameter passing in an array. The purpose of this method is to print out the array. The print table method uses a reference parameter. The local identifier ptable serves as an alias for the actual parameter grid passed to the method. When a program is running and it tries to access an element of an array, the Java virtual machine checks that the array element actually exists. This is called bounds checking. If the program tries to access an array element that does not exist, the Java virtual machine will generate an array index out of bounds exception. Ordinarily, this will halt the program. The most common 2D array algorithms will involve processing the entire grid, usually row by row or column by column. Problem solving a matrix could involve the processing 1 row, 1 column, 1 cell, and adjacent cells in different directions. Have a good time coding, and I'll see you next time.